questions do we want to see, do go over, have questions about? The ones I'm seeing the most are 1, 2, and 3, so we'll do this. So going back to literal equations, if we were solving this for w, we would need to get w by itself, get rid of everything else. So there are a couple different ways you can do this. One is getting rid of 2l by subtracting it to the other side. And then dividing everything by 2, but because things are going to simplify, do that separately. So that p over 2 minus l would equal w. Later when there's going to be a portion after we finish all the things we need to learn for the SOL, we're just going to do just SOL review. We're going to go over specific decimal types. And there is something specific about literal equations. I think if you put them all in with sliders, change the different values, put in your final answer, you could see if your answer matches or not. Questions on that one? The x and y intercept of number 2, there's one y-intercept and one x-intercept. The x-intercept should be at 2, 0. The y-intercept should be at 0, 2. And then number 3, to find the line of best fit, we're going to do that in Desmos. So if I were to make a table and put in all of my points, I can see the points are plotted. Then to find the line of best fit, I'm going to type in my y1 tilde, the squiggly line, mx1 plus b. So y and then 1. In the keyboard, the squiggly line, the tilde, mx1, and then plus b. And it's going to give you your m and your b, and you would write that in your y equals mx plus b format. So y equals negative 0.85, x plus 15.9. And that would be the line that best fits this data. Questions on that one? Print out your notes from last class. It should be these ones. I think these are those two last class. And again, we're going to start with expanding, but our goal is to figure out what the rule is so we could stop expanding. So we could go straight from whatever the problem is to the answer. So if we were to start expanding this, we know x to the third to the fourth, that would be x to the third 4 times. And because of the rule we learned last class, when multiplying like bases, we add the exponent. So if we were to add these together, what would our new exponent become? X to the power of 12. So be thinking, how could we get from the first part to the answer. We're going to expand one more time and see if we can figure out what that rule is. So here, if I have a to the negative 4th to the 7th, that would be a to the negative 4th 7 times. And you have a choice here. You can either change each of these using the negative exponent rule first and then combine them, or combine them and then use the negative exponent rule. It doesn't matter. So if we were to combine them, adding all the exponents together, what would that new exponent become? Negative 28. But then we can't leave this like this. How would we rewrite that? 1 over a to the 28. Anyone think they may know the rule? When raising an exponent to another exponent, you multiply the exponents. You can write that down here. So when raising a power to another power, or an exponent to another exponent, multiply the exponents. Matthias, make sure you're writing this down. So then look at the other examples. Which of those do we want to see, do, go over, have questions about on that page? 11. 9. Okay, so if we're using our rule, we can't do anything with this yet because this one has an exponent attached to it, but we can multiply these two exponents. So we have c to the negative 6. And because we haven't talked about dividing, what happens when we divide yet, I would just go ahead and use our multiplication rule, add the exponents, or in this case, add a negative, subtract. So our new exponent would be it is 5 minus 6. Negative 1. And then we rewrite this as 1 over c, or 1 over c first. Questions on 9 before we do 11? For 11, same thing, but you have to apply the exponent to everything, and that includes anything with a number. You have to remember that this has an exponent of 1, and so does the x. Think about this like you're distributing the exponent to the other exponents, or you're multiplying it. So here we have x to the negative 4th. This would become 3 to the 4th, x to the 4th, and y to the 8th. And then what you do next is really up to you. We do have to figure out what 3 to the 4th is. That's going to go out front, so let's do that first. What is 3 to the 4th? 81. Using our multiplying like bases rule, we have like bases, so we're going to do what with the exponents? Add them. So negative 4 plus 4 would give us 0. So I'm going to put x to the 0 just for now so we see what happens. And then y to the 8th would stay the same. And then anything to the 0 power is 1. So that means your x disappears. And really this is just 81 y to the 8th. Sometimes your variables and numbers may disappear by accident, so be careful. Questions on that one? If you know that's your phone, so silence it, please. Any other questions on this page? Okay, on to the next. Okay, so you probably could guess what the rule is here based on the other two, but we're going to expand just one of them, and then I want you to see if you can figure out what the rule is to get from here to the final answer. So if I were to expand this, we have a 6 times over a twice. And in this case, all the like a's would cancel, so it doesn't really matter if it's those two or a different one. And then there'd be 4 left. So what do we think that rule might be? When dividing like bases, you're going to subtract the exponent. So I'm going to write that down here. When dividing like bases, subtract the exponents. And then on this page, find which ones you want to see, do go over, have questions about. Any others? 17. I will, side note, 16 and 17 should have really been on the last page, but we'll still do them. Alright. 14. And then 8. Alright, so starting with 14, you have a choice. When you see problems like this, you can deal with the negative exponents first, or you can deal with them last. How you do that is up to you. If you want to deal with them last, and we're dividing, we're going to subtract the exponents, so I'm just going to set up what that would look like, but you don't have to write this part, you can do that. This would be c to the negative 1 minus 5, and b to the third minus a negative 4. Remember, you're subtracting no matter what. So then our new exponents would be what? C to the negative 6 and c to the 7. Then if you didn't do anything with your negative exponents first, you have to deal with them now. We can't have negative exponents in our final answer. So move the c down and make it positive. If you had dealt with the negative exponents first and changed this c and this d and swapped places, then you would be multiplying instead of dividing like bases, and then you would add instead of subtract. but you would get the same thing. Questions on that one? Okay. 15, similar. Just so you can see what happens. Let's say I did, actually, because we're dividing, let's not. Okay. Keep subtracting. So x, remember that this has an exponent of 1. So 2 minus 1 would give us 1. If you want to keep writing it out, you can. You don't have to. Negative 1 minus 4 would be y to the negative 3. 4 minus a negative 3 would be z to the 7th. And then the only thing that gets changed here is y. So x and z stay in the numerator, y gets brought down to the denominator. Have any questions there? With questions like 16, 17, 18, if you have an exponent outside of parentheses, you're going to multiply that to every exponent inside. So if you want to label what your exponents are, the ones that are ones, do that so you don't forget. And you're going to multiply the 3 to both of these and this 2, so that this becomes 4 to the third, x to the third, over y to the 6th. And then 4 to the third is what?
Eight more.
64. I think you were thinking whatever we just did before. So 64x to the third over y to the 6th. Yes. Okay. For 18, you have another choice. If you see like bases inside the parentheses, you can either deal with that first, think your order of operations, you can do that first, or deal with the exponent. It doesn't really matter because either way you get the same thing, and I'll show that in 1 second. So here, if we dealt with the inside first, we'd be subtracting. So it would be 2m to the third, still in parentheses, and then raised to the negative 4. And then here you have another set of choices. You could take this whole thing and flip it. I'm not actually going to do it this way. I just want to show you that this works. Take the whole thing and flip it and make the exponent positive and then deal with it that way. Or you could multiply all the exponents with the negative and then deal with it like that. Either way, you're going to get the same answer as long as you do the rules right. So both of these would get flipped. And it would be similar to what's going to happen in that one. 2 to the 4th is what? 16. Yes. And then m to the 12th. So in this one we did on the inside first. If you had done the outside first, I'm just going to do that, show that. You don't have to write this, but you can if you want. So if we multiply the exponent to everything on the inside, we have 2 to the negative 4, m to the negative 20, over m to the negative 8. Then you would subtract those exponents. Negative 20 minus a negative 8 is negative 12. And then we're back at the same place. So So then everything else would be the same. So it doesn't matter which way you do it. Any questions about that problem we just did? Go on to the next page. We're going to summarize and visit all the rules together, and then you'll have some time to practice, and then we'll come back and do some more problems. So these are, if you get stuck, this is a good place to start. If you have a number, an exponent outside of parentheses, distribute that number to the exponents or multiply that to the other exponents. If you have like bases that you want to move together, whether that be negative, positive, do that. You don't have to, but if it helps you, you can. This will say multiply. If you see like bases being multiplied together, add their exponents. If you see like bases being divided, subtract their exponents. If you want to deal with the negative exponents first, last, doesn't matter, move it across the fraction bar. And then if you have actual coefficients, 2 to the 4th, 3 to the 3rd, things like those, actually simplify them. And it doesn't have this. If you want to add this, remember that your 0 exponent rule, anything to the 0 is 1. Okay, so I'm going to give you like 15-ish minutes to do as many problems as you can on this next page. You guys can work together. I'll be walking around if you have questions, and you guys can go ahead and start that. 17, 17. Are there, any others? Listen. Alright, if we have others after this, we can add those on. Starting with number 4. So if you have just numbers outside, you're going to just multiply those. So 2 times 4 would give us 8. We have like bases for our y, but not for the x, so I'm just going to write x to the negative 4. If I added my exponents, this would give me y to the first. And then the 8 would come down because it has a negative. You can put y to the first, but you don't need it. But 8y over x to the 4th would be your final answer there. Questions? Okay. So 1, if you were expanding this, you are more than welcome to keep doing that. But remember that you want to try to use your rules, because you could miscount or something. Okay. Number 5, similar. Multiply the 4 and the 6. Add the exponents, so 4 minus 6, or 4 plus a negative 6, would give us negative 2. 4 plus 5 would give us 9. And then the 2 would come down. So 24 b to the 9th over a squared would be that final answer. Questions about that one? 7, same thing, we just had more variables. 2 times 5 would give us 10. Negative 4 minus 4 would be x to the negative 8. 3 plus 2 would be y to the 5th. Z doesn't have another like base, so just z to the 5th. And then x would come down. have any confusions about the ones we've done so far? Something not making sense? Okay. Number 12. You could do this one of two ways. Either take the whole thing and flip it 1 over 3u squared to the positive 6th power, or multiply it as is. So we have 3 to the negative 6, u to the negative 12, flip them both, and then figure out what 3 to the 6 is. What is 3 to the 6? Someone do that. So that would be 1 over 729 u to the 12. $14, I'm going to do the opposite of what I just did. I'm going to switch it first. Keep everything in parentheses. Not dealing with this negative exponent with the x yet. Multiply the 4 to everything, to all the exponents. Then, because I have a negative exponent in the denominator, that's going to move up. And someone tell me what 6 to the 4th is.
1,296.
So x to the 12th over 1,296, y to the 8th would be that final answer. And then we'll do 16. 16 had just a positive exponent, so no need to change anything. But we would have 4 to the 6, a to the negative 30th, b to the 36, sort of run into this, and c to the 12th. And a to the 30th is going to get moved down. Someone tell me what 4 to the 6th is. $4,096. So this is a really good example of why we don't want to keep expanding. Just imagine writing out 30 A's and 36 B's. It's a lot. So 4,096, B to the 36, C to the 12, over A to the 30th. Questions on any of those ones? Or confusions? Anything that doesn't make sense? Okay. 17. When you are dividing, you're actually going to divide the numbers unless they can't be simplified. So in this case, they would stay the same. Subtract the exponent. So negative 4 minus a negative 1 would be 5 over 6 times b to the negative 3. And the b would come down. So 5 over 6b to the 30. 19, if I were subtracting my exponents, the 5 would stay in the denominator. We're not changing that. 5 minus 6, I'm going to write it like this. 1/5 times m to the negative 1. Negative 6 minus 5 would be n to the negative 11. So m and n would both come down. We would have 5 to the m, n to the 11. And then in 22, you have a bunch of zeros and negative exponents. You can deal with those first or subtract and deal with those after. It's up to you. So 2 divided by 2 is just 1. negative 1 minus 0 is m to the negative 1. 0 minus a negative 2 is n to the positive 2. M comes down. So your final answer, n squared over m. Questions on any of those? Go on to the next page. Now we're going to look at just 1 through 8 first. Any of those we want to see, do go over, have questions about. We'll start with 8. If we have any others, we will do those. So 8, I'm going to ask, what math operations do you see? Adding, subtracting, multiplying, dividing. Multiplying. Anything else? Dividing. And dividing. So if we were multiplying and we had like bases being multiplied, we would be adding the exponents. But because we're dividing like bases, we're going to do what with the exponents? Subtract. So those are the questions you need to be asking yourself when you see a problem. What's happening? What do I need to do with the exponents? Actually divide the numbers. So negative 28 divided by 7 will give us negative 4. Subtract our exponents. So x to the negative 8 minus 2, what would our new exponent be? So not negative 6, but negative 10. Negative 8 minus 2. And then our exponent for y? Negative 4. And then we have to change this problem. How would that look? How would we do that? So the negative 4 is actually going to stay in your numerator, but the other two are going to come down. So negative 4 over x to the 10th, y to the 4th. Questions on that one? Any confusions? Something doesn't make sense? Other questions in sections in that section 1 to 8? This one, right? Okay. This one's going to be similar. Same operations, we're multiplying and dividing. So if we were dividing 5 over 20, leave that as a fraction, what would that become? 1 over 4. And then subtract your exponents. 8 minus the negative 2 would be 10. And this is 1. 1 minus 6 would give us negative 5. So then we're going to change the negative, move it down. The x is going to stay up. What would that look like? What would our final answer be? Yes. X to the 10th over 4y to the 5th. We don't have other questions in the first section. Look at numbers 1 through 5 on the bottom. Any of those we want, see, do go over, have questions about. Number 3. We'll start with those. So number 3, what operations do we see there? Multiplication. And there's something else happening. So if we had like bases afterwards, we will be adding the exponent. But because we're raising exponents to another power, that's the other thing that's happening. We're going to be multiplying. So multiply your exponent, your outside exponents to all of the inside exponents. A to the 15, B to the 10, 4 to the second, A to the negative 6, B to the 12. Now that we have like bases and we're multiplying like bases, we're doing what with the exponents? Adding. We can also, you could do this simultaneously, but 4 squared is what? 16. And then if we're adding our exponents, A to the 15 minus 6, what would that new exponent become? A to the what? To the 9. And then what would our new exponent for B become? 28. So 16a to the 9th, b to the 22nd. Any questions, confusions on that? Number 5, we are dividing and raising an exponent to another exponent. We can't divide because of the parentheses. So we have to deal with this first. Multiply all of your exponents. 3 to the 4th, a to the 12th, b to the 16. And then because we're dividing like bases, we're going to do what with the exponents? Subtract. Also, because we have a base of 3 in our numerator, and we know 9 is the same as 3 squared, if you wanted to change 9 to 3 squared and subtract the exponents there, you could. Or you could figure out what 3 to the 4th is and divide it by 9. Either way, it doesn't matter. What is 3 to the 4th? 81. If we're dividing, we'd have a to the 7th and b to the 7th. And then 81 over 9. 9. So 9a to the 7th, b to the 7th. Other questions in numbers 1 through 5? Look on the back, and then this will be the last thing we do today. Numbers 6 through 8, questions on those.
Eight.
I will say that 6 and 7 are similar to number 3 that we just did, except 6 has 2 numbers on the inside instead. 8, what operations are we doing? Or do you see? We are multiplying, we are dividing, we will be subtracting, and we are raising an exponent to another exponent. So, do we want to do what's on the inside first, or deal with the outside first? Okay, so if we're dealing with the outside first, multiply that exponent to all of your inside exponents. 8 to the 3rd, c to the 27th, d to the 12th, over 4 to the third, c to the 15th, d to the 18th. And then we are dividing like bases, so we're subtracting. And then we also need to figure out what these two are. 8 to the third power is what? 512, thank you. If we're subtracting 27 minus 15 would give us 12, c to the 12th, and then d to the negative 6. 4 to the third is 64. So if possible, if we could simplify 512 over 64, do that, or see if you can just divide it outright. 8. The d is going to come down, c stays up, so 8c to the 12th over d to the 6th would be our final answer. Overall, how do we feel about simplifying exponents? Good, okay, need more practice, not good, I don't understand this at all. I am going to show you how you can check yourself in Desmos. We talked about this before when we were going over the SOL review. Feel free to go back to that section, SOL 8.2, to see if you can try those problems now and get the right answers. But in Desmos, let's say that I put in number 8. Since we just went on. I'm going to put it in with all of the variables that we have. So 8. 9. It's going to ask you for sliders, add all of them. Change them to some positive number, just because negatives get weird if you have even bases. We don't want to have to worry about any of those. Change them to just something different. And then put in your answer. So we got 8 c to the 12th over d to the 6th. And if your decimals are the same, you know you did that right. So you can't really do this in Desmos, but it's a good way to check yourself. Okay. So as you are working through Delta Math, if you go back to that SOL practice, any of those, so you do have 2 Delta Maths that are due today, the classifying insight and simplifying exponents. You guys have your SOL 8.4a and 4b that are due on next Wednesday because of the no school on Tuesday. You have extra practice in your notes. If you want to go back to the previous SOL to try those. If you would like even more practice, I have exponent review books that just has more of the exponent rules. Feel free to grab one of those if you would like. But use this last bit to practice, and I'll have you guys put calculators and iPads away when there's like 10 or so minutes left.